I'll explain about full adder designing using Microwind or DSCH 3.9. As we know that this is the full adder circuit, we can use this one, otherwise one more format also we can use any circuit, because the different methods are there to designing full adder circuit. We'll take one of the full adder. So for that, just first open the DSCH 3.9 here. So this is the full adder and this is the truth table for that, and then we need to open, that is DSCH 3.9. So this is the 3.9. Go for file and then select foundry 45 nanometer technology. You can use another one also. So then right side, that is basic symbol library is there. Whatever the components, whatever the required are required. So we need to take and select that and take it here. So one by one I am taking the using, so here, so I will take one by one the full adder required transistors. So then we can see this, this is the wire option. Click on the wire option. So then we can easily give the connections, as we know that. Click on the wire option and then we need to give the connections, and one input button, input buttons are required, and the full adder is required 3 inputs, 3 buttons are required, and here this is the button, and then we need to give the connections, and so we need to give the connections. This is the third input, and then give the connections. As you know that this is the circuit, then as per that we need to give the connections. Just give the, click on the wire option and then give the connections. I am giving the connections by click on the wire option, and we know that it is having sum and carry, and so this is the carry. I am using this circuit. This is also full adder circuit. Will get the output, and 2 LEDs are required to get sum and carry outputs. I am taking sum and carry. That is, this is the sum, and this one is that is carry output, and this is the sum output. So give the connections, and now here you can see this top side there is a run option is there. Click on that. There is a run option. Now we can see this is the run option, green color button. So run simulation. Then we need to check while giving 0 0 0 what is an output, sum and carry 0 0. While giving 1 0 0 what is the sum and carry, 1 and carry is 0. And similarly we can check all the outputs and by using truth table. So like this we can design, that is DSCH 3.9 the full adder circuit. After this we can go for, that is logic simulation, that is timing diagram. We can see that I will check. This is the timing diagram. To get timing diagram, click on this here top side. That is the timing diagram option is there. Click on that. This is the red color, this one. This is the timing diagram. Click on that. This is the timing diagram, and then simulate. Go to simulate to get to truth table, and go to simulate. This is the timing diagram, and then go to simulate and click on truth table, logic simulation, and then extract truth table. You will get the truth table output. So this is also one more option, and then close it. Then file, save as. This is the important one. File, we can save it any folder. I am saving, my folder is in documents. I am saving as RR2 in documents, and in that this is the file, my file. So RR2, saving as a RR2. So now we need to convert. This is also important step. Make a Verilog file. Go to file and make a Verilog file. So this is the important step. don't forget, otherwise you may not get the output. File, make a Verilog file option is there, click on that and update Verilog and click on OK. Then only we'll get the output. Then minimize it. Then we need to go for second, that is front end process is completed. Then we need to go for back end. For that we need to open the Microwind tool. Till now we have done in DSCH 3.9. Then we need to go for second option, that is DSCH 3.9. For that again go for file and select the foundry 45 nanometer technology as you have used in earlier. Same only need to select. Then this is the one step, that is go to compile and select compile Verilog file. Then need to open our saved file, that is in documents folder RR2. I am opening that. So after getting the open, so click on compile. So need to get 0 errors like this. So if any error is there, we'll get errors of course, but after this click on back to editor. So we'll get click on back to editor. So now this is the diagram for the, that is backend, that is mask layout diagram. We know that is green color is for N diffusion and red color is for polysilicon, blue color is for metal connections. This is the VDD and this is the supply. Sorry, this is the supply and this is the ground and these are the inputs and this is the output one, sum and carries. So after this we can also observe the 3D view. So by the top corner we can see this 3D option is there. So click on that 3D in the top side. Click on that 3D option, 3D. So this is the 3D. Here you can see this. Click on that and we'll get 3D diagram. So this is the fabrication process 3D diagram. We know that if you remove the metal means what, that is blue color. So click on that. If you want to see the particular component you can select, otherwise we can deselect. So this is the mask gate and you can go with metal. So like this you can observe the layer components easily. So then close it and then go for again one more option is there, step by step fabrication process. So that is to get that here one more option is there, one more option I will show you. Here then you can see this 3D. Here there is option, that is fabrication process. Click on that and this is the fabrication process step by step, and gate deposit process, implant process, P implant process, FRAM, that is to gate positions. Like this we can see that is fabrication process step easily 3D in the form of 3D view. So this is the way we can design full adder circuit. So we know that this is the mask layout diagram and we know that this is the front end designing process. Thank you.